Hello everyone. Today I am going to explain the fourth problem of Leetcode Weekly contest 384, which is number of Subarrays that match a pattern 2. So the second problem of this contest is also same, but the constants are different. Here the constants on num's length is 10 to the power 6, and there the constants is around 118. So what is the problem? So problem is that we are given some array nums, and we are also given some pattern. So pattern consists only -1, 0 and 1. So a substring of length m plus 1 of nums is matching with the pattern if the following three conditions are satisfied. If nums of I plus k plus 1 greater than nums of I plus k, then pattern k should be 1. If they are equal, then the pattern k should be 0, and if the next character is next integer or next number is less than the current number, then the pattern k should be -1. So let's look at the first example 1 2 3 4 5 6. So let's look at the first example 1 2 3 4 5 6, and our pattern is what? Pattern is our 1 1. So 1 1. So 1 1 means that let's say 2 is greater than 1, so the pattern value should be 1 here. Now we are building some B array. So B array will give us the pattern values. So 2 is greater than 1, then the value should be 1. Now 3 is greater than 2, the value should be 1. 4 is greater than 3, so the value should be 1. 5 is greater than 4, value should be 1. 6 is greater than 5, value should be 1. So this is our B array and this is our pattern array, you can see. Now what we have to do check is that we have to check every subarray of length 3 or length of pattern plus 1. So we are checking the first three characters. The first three characters will give us this B value. So these are matching with pattern, so answer will be 1. Okay, now we are checking 2 3 4, then the pattern value should be this 1 1. This is also 1, so we are adding 1. And then we are taking 3 4 5, the pattern value is this one, this is also matching, plus 1. Then we are taking 4 5 6, pattern value is this, the pattern is matching, so answer is 4 here. So our answer will be 4. So this is quite straightforward example. So let's take another example. Let's take this example only, 1 4 4 1 3 5 5 3. So let's take this example, 1 4 4 1 3 5 5 3, and what is the pattern value? The pattern value is nothing but 1 0 minus 1. So pattern value is 1 0 minus 1. So let's construct B array here. 4 is greater than 1, so let's the B array value will be nothing but 1. 4 is equals to 4, so B value will be 0. 1 is greater than 4, 1 is less than 4, so the value will be -1. 3 is greater than 1, 1 again, this is 1 again, this is 0, and this is -1. So this is our B array and this is our pattern array. Now we have to check every sub array of length 4. So we are checking the first sub array of length 4, and the pattern value is 1 0 minus 1. This is matching, so answer will be 1. Okay, now we are checking 4 4 1 3, the pattern value is 0 minus 1 1. This is not matching, so this will be 0. And we are doing again for this 4 1 3 5, the pattern value is -1 1 1, so this is also not matching, so this is 0. And we are doing for 1 3 5 5, right? We have 1 3 5 5, the pattern value is 1 1 0, that is also not matching. Then we are doing for 3 5 5 3, the pattern value is 1 0 minus 1, this is matching, so answer will be 2. So let's check answer. The answer is 2. Okay, so that's how we are doing this, we are solving this. Now I have already told the time complexity could be this is 10 to the power 6 is the length, n is 10 to the power 6, so the overall time complexity could be order of n or order of n log n. So what is the observation? Let's look at the observations now. So the observation is quite straightforward here, that let's say this is we are constructing the B array. Now our answer will be nothing but the number of occurrences of P in B. Okay, that is quite simple. So we have built the B array and we have to find the number of occurrences of P or pattern in B, and that's the count will be the answer. Okay, so how we can do this? For getting any occurrences of a pattern in a string, we can use any algorithms. The brute force algorithm is order of n squared, which is not acceptable here, but we can do other things, right? We can do string hashing, or here string hashing will not be used. You can make this as a string, right? because these are only 1 0 minus 1, you can map 1 with A, 0 with B, and minus 1 with C, and do string hashing. This is one possible case. So the time complexity will be order of n. And another case you can use here, what I have used is this is string hashing or KMP. You can this is rolling hash, string hashing or rolling hash, but I have used KMP, which is also order of n. You can use KMP. So I will explain the KMP solution to you, but you can also use string hashing. So let's look at the KMP algorithm. So what KMP algorithm does, I will not explain the entire algorithm, but I will explain the gist of it. So KMP algorithm finds one array which is called LPS. LPS means longest prefix, which is also a suffix in the pattern. So here AB is not matching, so this will be 0 0. Now this character A matches with the first character, so this is the suffix of A is also matching with prefix, so this will be 1. Now these two characters are matching with the first two characters, so the LPS value will be 2, and here this is not matching, so the LPS value will be 0. So this is the LPS of the pattern is nothing but 0 0 1 to 0. Now what is the algorithm, how we are finding the pattern, existence of the pattern in the string? So we'll do I equals to 0, j equals to 0. So we'll try to match this A with this A. The first, let's say this is I is iterating over the text, and j is iterating over the pattern. So I and j are matching, so we'll increment the value of I and then increment the value of j. Okay, now this character and this character is also matching, so we'll again increment the value of I and increment the value of j. Now this character and this character is matching, so we increment the value of I again and increment the value of j again. Now these are also matching, so we have incremented the value of I is now here and j is now here, but these two characters are not matching, so we'll make j as LPS of j minus 1, because in our brute force algorithm we have to start from the we have to iterate, we have to backtrack the I in pointer, but here we are not backtracking the I pointer. Instead we are making j as LPS j minus 1. So LPS j minus 1 is 2, so here the our pointer will be at this index now. Okay, because this is 2 and we are making the our j equals to 2. Now we are checking that A is matching with this A, so we'll increment the pointer, I pointer and j pointer, and again these two are matching, so we'll increment our I pointer and j pointer. Then these are matching, so we have found one occurrence, so we'll increment our answer variable by 1. Okay, so that is the KMP algorithm, how we can find the occurrence of any pattern in the given text. Okay, now let's look at the code, how we are using it and how we are modifying it to find the count instead of finding the true or false, if it exists or not. So let's look at the code. So here this is the I have copied this part of the code from GFG, and this part is for finding the LPS array. You can look at the code in the GFG, or you can look at YouTube also. I'll provide some link of good tutorials in YouTube how we are constructing the LPS array. Now here this is the KMP search. So initially we have initialized the I pointer and j pointer to 0. Now if the pattern of j is matching with text of I, we are incrementing the value of I and incrementing the value of j. Now if j equals to m, that means that we have at the end of the pattern, that means we have found a match. That's why we are incrementing the value of brace here. We are incrementing the value of brace here. Now let's look at some one more case. There, by that way you will find why we are doing this. Let's say our text is a and our pattern is nothing but 3s. Okay, so for the 3s the LPS value will be nothing but 0 1 and 2. So this is matching, so we are moving pointer to here and moving this pointer to here, and this is matching, so we are moving the pointer to here. Now the length of j is now m, so we can backtrack our j to this 1. Okay, we are backtracking our j to 1. Now again we'll check this character and this character, they are matching, so again our j is at m. That's why here when we are incrementing the value of brace, we are doing j equals to LPS of j minus 1 instead of setting j equals to 0. Okay, now similarly if j not equals to 0, we are doing j equals to LPS j minus 1. That is our previous algorithm for finding the occurrences. and otherwise we are incrementing the value of pi. If you like this video, please like and subscribe. I will provide the link of the codes in the description box. Thank you.